Hey, what's up everybody? My name is Moss, and in this video, I'll be giving you a recap of the sessions that I attended on November 14th at KubeCon 2024. In this series, I'll be providing daily recaps of the sessions that I attended at KubeCon 2024, as well as interviews I conducted with industry experts at the conference. Thursday was a continuation of Solution Showcase, but after the sessions had ended for the day, Splunk hosted an event at a rooftop bar. And not only were there drinks and food, but the venue offered a great view of the Salt Lake City skyline. Let's get into the session summaries. The first session that I want to cover was about mastering OpenTelemetry Collector configuration. And in this session, the speaker explained the high-level architecture of the OTel collector. And he actually demonstrated how to write a service pipeline in the OTel collector and explained how its components work. And part of the discussion focused on how flexible OpenTelemetry is because of its vendor-agnostic characteristic. The goal here is to instrument your applications only once and have full control over your telemetry data. And not only that, the OTel collector has multiple distributions to support a variety of use cases and environments. For instance, if you're using Splunk Observability Cloud, there is a Splunk-specific distribution of the OpenTelemetry Collector that you can utilize. And this distribution can simplify your deployment and configuration of the OpenTelemetry Collector when using it with Splunk Observability Cloud. When demonstrating example configurations for the OpenTelemetry Collector, the speaker also talked about best practices for scalable configuration, which included utilizing the right processors like the memory limiter and batch processor. For instance, if you implement the batch processor in your pipeline, rather than sending each telemetry data point over the wire immediately when it's received from a data source, it will batch multiple telemetry data points together before sending those data points over the wire to your observability backend. The next session I attended was about lessons learned when adopting OpenTelemetry at scale. The speaker discussed strategies for adoption, which included simplifying the integration of OpenTelemetry for teams and also employing strategy from Dale Carnegie's principles. I think if you're trying to get buy-in from development teams when implementing an observability solution like OpenTelemetry, it's incredibly important to define an easy on-ramp for their team to integrate the observability solution into their project. The speaker then talked about some of the lessons that they learned, which included standardizing observability practices and implementing semantic conventions early on in the process. Agreeing on semantic conventions early on prevents a buildup of technical debt. And where possible, you should be utilizing infrastructure as code to manage observability infrastructure like your dashboards and alerts. If you're managing an on-premise observability solution and you're manually creating your dashboards and alerts, it's not only less efficient than implementing infrastructure as code, but it's also more prone to error. Now, one of the important lessons that they discussed here was how they reduced data transmission by using exponential histograms and efficient aggregation methods with their telemetry data. So if you're looking at a metric in a histogram like the duration of HTTP requests, the default histogram configuration was using fixed bucket sizes with a limited range of duration. So instead they used exponential histograms, which were dynamic based on the value of the data that was being received by the collector. And they created a custom aggregation method. So instead of sending the actual metric values, like for a particular request, the duration was 5 seconds. Instead of doing that, they would just create a count of all of the requests that were in a specified range that would cover that value. So for instance, let's say there was a bucket for duration 4 to 5 seconds. And all of the requests that fell within that range, they would just increment a count and then send that count over the wire rather than the actual duration value of a particular request. And in doing so, they greatly reduced the amount of data being transmitted to their observability backend. The next session was kind of a deep dive into Elastic's eBPF profiling agent. And the problem that the profiling agent is trying to solve is that companies currently have a difficult time trying to map CPU consumption back to specific lines of code in their applications, as well as tracking performance regressions over time. For a lot of companies, implementing profiling hasn't been exactly practical or easy to implement. And the eBPF agent addresses some of the practicality issues by utilizing less than 1% CPU and about 250 megabytes of memory. And in this session, the speaker demonstrated how the profiler captures stack traces from the kernel through higher level language runtimes. The agent supports continuous profiling of multiple languages. And you can perform more efficient debugging, performance regression tracking, and resource optimization with the agent. You're able to gain deep visibility into an application's behavior at scale and in a production environment. Not only that, the speaker demonstrated how the eBPF agent integrates with the OTLP profiling signal. The final session that I attended was on multivariate anomaly detection. And I thought this was a pretty cool session because it demonstrated the practical application of machine learning and statistical methods to more quickly identify and resolve incidents. And the core motivation behind this is that individual metrics alone don't necessarily indicate service degradation, as well as static thresholds tied to those metrics. I think every engineer is familiar with alerts that are false alarms and unnecessarily pull your attention away from your work. So you can create high-value metrics with multivariate anomaly detection. And these high-level metrics are built using statistical methods and machine learning models. Rather than looking at an individual metric and a static threshold tied to that metric, multivariate anomaly detection will look at all of the metrics together and find correlated insights and utilize context to identify whether or not an anomaly is occurring that you should look at. I think a rough analogy or comparison of multivariate anomaly detection metrics would be to something like the load metric that you would see on a Linux machine. Load metric is comprised of multiple individual metrics, and it kind of gives you a rough idea of what's happening in the system and if the system is under pressure or not. And I would say that the multivariate metrics are probably much more insightful than something like the load metric is on a Linux machine. In addition to discussing the high-level concepts, the speaker also explained how you can implement multivariate anomaly detection yourself, leveraging open source tools and frameworks like OpenTelemetry. And you would pair these tools with machine learning models to generate multivariate metrics. I've linked the full recording of each of the sessions I attended in the video description below. I hope you enjoyed this video, and if you did, we'd love to hear your feedback. If you're interested in learning more about some of the topics that were discussed in this video, like infrastructure as code for observability or OpenTelemetry configuration, check out the content I linked in the video description. And be sure to stay tuned for more videos from my time at KubeCon 2024. I'll be posting daily recap videos as well as interviews I conducted with industry experts at KubeCon. Thanks for watching.